Now let us see the family of circles. Suppose that we have a pair of circles, say S1 equal to 0 and S2 equal to 0, such that they intersect each other in two different points, right? Now suppose we want to find out what is a general equation of a circle that passes through these 2 points of intersection. So that means there might be one circle that might be passing through the 2 points like this, whereas there might be another circle, a smaller one, that also passes through the same 2 points of intersection, and so on. We can sense that there are actually infinitely many circles that pass through the 2 points of intersection. So the general equation for the family of all those circles is given by S1 plus lambda times S2 is equal to 0, where lambda is called as a parameter. That means for one particular member of that family, lambda will have a specific value. And of course lambda cannot have the value as -1, because that would give us S1 minus S2 equal to 0, and that means S1 equal to S2, indicating that both the circles are same, but we want the two distinct circles, so the parameter can't be -1. Now there is a second case where a circle is intersected by a line, alright, or it could be touched by a line also. So that means there could be a secant or there could be a tangent. Now the equation of the circle we denote as S equal to 0, and the equation of either the tangent or the secant we denote as L equal to 0, indicating that it's a line. Now here also, if you see, in case of a secant there are 2 points, and through these 2 points there will be countless circles that could be passing, isn't it? In case of the tangent, through the point of contact also there will be countless circles that would be passing, which touch the line at that point. Alright. So in both of the cases, the general equation of the family of all these circles is given by a similar pattern, but in case of circle we'll write S plus lambda times L is equal to 0. So that is very much analogous to the pattern that we saw earlier. It's just that there are two curves, either both are circles or one circle and one line. Alright. Now typically in the questions an additional information will be supplied so that we can calculate the value of lambda, that's a parameter which is specific to that specific member of the family, and once we get lambda we put it back into the same equation so that we get the actual equation of that specific circle. Let us solve one example so that this process will be clear. Find the equation of circle passing through point 1, 1 and the points of intersection of the two circles as shown here. Alright. So that means we have the first circle we can denote by S1 equal to 0 and the second circle as S2 equal to 0. Now in general the equation of any member of the family of circles is given by S1 plus lambda S2 is equal to 0. So that means in place of S1 we substitute this particular expression, and in place of S2 we substitute the other equation, right? So therefore let us write it as x square plus y square plus 13x minus 3y plus lambda times expression for second circle, so that is 2x square plus 2y square plus 4x minus 7y minus 25 equal to 0. So this represents the family of all those infinitely many circles in general. Now we want to find out that specific circle which passes through 1, 1. So that means if we substitute x and y with 1, 1 in the above equation, that will give us the value of lambda, and we don't solve that here, it's simple substitution, and on solving it we will get the value of lambda as 1 by 2, and therefore on putting it back in the entire equation once again, we get the equation of the required circle as 4x square plus 4y square plus 30x minus 13y minus 25 is equal to 0. So you can verify by putting lambda equal to 1 by 2 in the above equation. That is the equation of the required circle.